Guys, welcome back. So what we're looking at today is 7.10 sand castles. So let's go ahead and jump right in. So what we're looking at here is we want to locate the center of each circle below. So hint, use the chords of the circle to pinpoint the center. So remember, we've looked at something similar before. A chord is any line that goes from one side of the circle to the other. It does not have to pass through the center. So if we draw a chord, my goodness, my line is not straight. We draw a chord here, and let's say we have another one that's here. We can extend these lines out. We bisect center here. We find the perpendicular bisector of this and the perpendicular bisector of this. And so our point is right there in the center. So there is our center. You can also just take and find the diameter of the circle across, and then your circle's in the center. Or your center is in the circle where it crosses. So justify your work finding the center of the circles above. Why does it work? Why does it pinpoint the center of the circle? So perpendicular bisectors of chords contain all the points that are equidistant from the endpoints of the chord. By constructing two of these, their intersection creates the center of the circle. So let me shrink this down. Perpendicular bisectors of chords find all points equidistant. So the intersection creates, that's supposed to say creates, goodness, center. He didn't give much space to write here. So in circle 1, draw a central angle and an inscribed angle that cuts the same arc as the central angle. What is the relationship between the measure of a central angle and its corresponding inscribed angle? So for this, you can draw any angle. You just have to draw that central angle and an inscribed angle that cuts the same arc. So this angle here, so let's say this is A, this is B, and then we could have, that's supposed to intersect back there. Let's say that's C. So they would intersect the same arc. This is 90 degrees, so the arc would be 90 degrees. This would be 45 degrees. So the relationship is inscribed angles are half the central angle. So in circle 2, which obviously I drew them backwards, draw a central angle and a circumscribed angle that cuts the same arc as the central angle. What's the relationship between the measure of the central angle and its corresponding circumscribed angle? So a circumscribed angle is supplementary to the central angle that intercepts the same arc. So circumscribed angle would be extending it to the outside. No, sort of. So same arc, but it's got those lines coming on the outside, so it's extending off like such. So supplementary to central angle. All right, so the next part of what we're looking at is all about volume and surface area. So finding the volume of a prism, we are taking and multiplying all three dimensions. So 9 times 8, so volume equals 9 times 8 times 20. When we multiply all of that together, we get 1,440 feet cubed. Now, for surface area, this is where it's a little trickier. We have to find the area of all of the faces. So this square here, the 9 times 8 is 72. In the back, it's also 72. So surface area, we have 72 plus 72 plus this side right here is 9 times 20. 9 times 20 is 180. So that side over there is 180. So we have 180 plus 180. And then we have, let's see, that's 4 sides. So then the top, which is 8 by 20. So this up here, 8 by 20. So 8 times 20 is 160, plus the bottom would also be the same, so 160. So then we add all of that together, and we're going to get 824 feet squared. So surface area involves a lot more work because you have to find the area of every single one of the faces. So all 6 of them when you're dealing with a rectangular prism. Now, 8 will be the exact same thing. Multiply all your values, find each of the faces, add them together for surface area. But 7 and 9 are interesting. It's based on what you do for 6 and 8. So number 7, a prism similar to the one on the left has been enlarged by a factor of 4. So you don't have to draw this. You don't have to take and do anything like that. All you're doing is you're going to use that factor. So if we have the factor of 4 and we're dealing with surface area. So area is a squared value. So that means we're going to take and multiply our surface area. We're going to take 824 and multiply it by 4 squared because that's how much of a difference it's going to be, because we're not just taking a two-dimensional thing and enlarging it. We're taking a three-dimensional thing and enlarging it. Surface area is two-dimensional, but we're taking more than just a single value. We're taking area, so we have to square it. So when we take 824 and multiply it by 4 squared, we're going to get 13,184 feet squared, because each of your dimensions is 4 times larger. So if we multiplied 9 by 4, we'd have 36, and 8 by 4 would be 32. And if we multiply those, we'd end up with 1,152. Now, if you divided that by 72, you'd find that it's 16 times bigger. So that's why we multiply it by 4 squared. Now, for volume, you're dealing with a cubic unit. So we're going to multiply by 4 cubed. So we're taking the 4 cubed, which is 64, and we're going to multiply it to our 1,440, and we find that that's 92,160 feet cubed. So that is how you find those. So it's enlarged. This one's also going to be enlarged, factor of 3. So that means you'll be multiplying by 3 squared and 3 cubed once you find your values for 8. Okay? All right, now for cylinders. So now we're looking at volume and surface area of a cylinder. So volume of a cylinder, this is our equation, pi r squared h. Surface area of a cylinder, a little bit more work. So 2 pi r h plus 2 pi r squared. Okay, so for number 10, we're going to find the volume first. So volume equals pi r squared, the radius is 3 on the circle, times the height, which is 8. Oops, that should be squared. So 3 squared is 9. 9 times 8 is 72. So the volume equals 72 pi feet cubed. So then for surface area, we'll have 2 pi times 3 times 8 plus 2 pi 3 squared. So in this first part, 3 times 8 is 24, times 2 is 48 pi plus 3 squared is 9. 9 times 2 is 18 pi. So when we add 48 and 18 together, we end up with 66 pi. So our surface area is 66 pi feet squared. Now, same thing as what we did on the last one. We're doing an enlargement of the cylinder. So we have a factor of 2. So for volume, we're going to take our 72 pi and we're going to multiply it by 2 cubed. So multiply it by 8. So 72 times 8 is going to give us 576. So the volume equals 576 pi feet cubed. And for surface area, we're going to take that 66 pi and multiply it by 2 squared because it's area, so by 4. So 66 times 4 is going to give us 264. So 264 pi feet squared. So same idea for 12 and 13, okay? The last part. So we're looking at converting our radians and degrees again. So this part's a little bit of a review. So remember to go from degrees to radians. We do 120 over 180 times pi. So we have 12 over 18, which will reduce down to 2/3. So it's 2/3 pi for our radians. For our degrees, so we're going to do 18 together because it's a little weird. So we take the 4.7 and we actually divide it by pi because it's already been multiplied by it. That's the only way we could have that decimal. And then we multiply that, because that'll give us 1.49, times 180, which will give us 269.3 degrees. So when you have a decimal, just divide it by pi and multiply by 180. But just reviewing that, converting our degrees and radians. So like for this one, 360 over 180 times pi, and that's going to give us a 2 pi radians. All right, our next section is finding the area of each sector. So remember, area of the sector, we do 100 over 360 times pi 13 squared. So 13 squared is 169, and we're going to multiply that by 100 divided by 360, which is going to give us 46.9, and then we multiply that by pi to get 147.5 centimeters squared. Then for 26, we're finding the arc length. So here we're going to take 60 over 360 times 2 pi times 50. So 2 times 50 is 100. So we take 60 divided by 360, which is 1/6. And then we multiply that by 100 to get 16 2/3. And then we multiply that by pi to get 52.36 inches. So a little bit of review on this last page here for what we are working on today. So your keyword for this lesson is volume. Volume is your keyword for this lesson. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.